The last chapter we're going to do in this class is chapter 15, cluster analysis. We're going to use utilities data set that has like 22 public utilities, and there are some predictors right here. We're going to find clusters of the observations here. So there are 22 rows of data, and we're going to cluster the observations, the rows of data into, and we'll use two different approaches. We're going to do the agglomeration approach, where we start from each observation being a cluster by itself and then keep building up, aggregating it all the way up, where the entire data set is one cluster. So then we can choose anywhere in between the one cluster on one end and each observation being a unique cluster by itself on the other end. And then we will use k-means clustering. Again, we'll use the same data set, and we will apply k-means clustering method. Okay. Both these methods are part of the base R, so we don't really need new libraries, but we will need libraries for plotting the k-means centroids. I'll show you what we need to do at that point. So let's start with setting up our path to the default folder. Okay, then let's read the data in. We'll call it utilities.df, read.csv, utilities .csv. Okay, so now we have the data in. The first column is the name of the company, and then we have all the predictors. Okay, we don't need the name of the company, because name of the company is not a not a variable that we can use in computing distance measures. So we can get rid of this column, but it is better to retain the company names, because when we do the clusters, then we would want to know which company is in a given cluster. And so instead of simply saying, the row numbers 1, 5, and 10 are in a cluster, it would be nice if you could say companies Arizona, New York, and Madison, they are in one cluster, right? So we want to keep the company names. So what we're going to do is to move the company names into row names. Since the rows being 1 through 22, instead of that, we will use the company name as the row name. So what we need to do is to set row names. So the function for that is row names, and then we say utilities. So the row names of utilities.df. Okay, and we say, okay, let's use the first row. So utilities.df, first column, sorry. Okay, so it'll take the first column and use those values as row names. So when you run that, and if you go back and see that company names are now used as row names. So now we can get rid of the first column. So remove first column. So utilities.df. Okay, we set that to utilities.df. All the rows and columns -1. So first column is now removed. Okay, run that. Then you see the first column is gone, and we only have the predictors, and the rows are named by the company names. And the only reason we want to do that is, as I said, when we do the clusters, we will know which companies form a cluster and not just row numbers. Okay. Now we can now find the first thing to do before running the clusters is to find the distances. Um, Now we can do the distance using the distance function. Okay, dist is the function name. So it's in basic stat package of base R. And then you give the name of the data set, and then we do a method. So method equal to, you can specify what method we want to use, and we will use Euclidean. Euclidean. Okay, and then we'll print the distance. Okay, so now print the distance, and you see for each of the observations we have the distance from that observation to each of the other observations. So each observation, so there are 22. So you take the first observation and find the distance between that and the rest of the 21 observations. So do the same for the second, the third, and so on. Okay, so that's your distance matrix. But remember, when we are computing distances, the magnitude of the variable values can skew the distance measures. It will cause a bias towards variables that have really large values. So we need to normalize, and there is an easy method for normalizing, and that is scale. Now scale is a function that you give a number and then a column, and then whether centering is true or not and scaling is true or not. So centering is subtracting the mean, scale is dividing by the standard deviation. But those two are default, so we really don't have to specify that. Now we want to apply this to each and every column, right? So we can use the apply method. So let's say utilities, and we'll call this utilities .df.norm. Okay, normalized. Okay, so instead of apply, remember we have a couple of other applies. Now S apply. Okay, it's now the margin is by column wise. Okay, you can't use this for row wise. The apply function, you can specify the margin as 1 or 2, if you want it by column or by row. But S apply is always column, so you don't have to worry about specifying the margin. So you say, okay, we want to apply this to utilities.df. Okay, if you are using apply, then you will specify the margin at this point. Now no margin because this is column wise, so you specify what you want done to each column, and we say scale. So scale is automatically going to assume centering is true and scaling is true. So run that, and that will find the normalized values. So if you look at utilities.df.norm, and you see all the values are normalized. Okay. Now this normalized data frame, okay, row names are now not the company names, but row names are 1 through 22. So we want to specify the row names for this data set to be the same as the other one. So you say utilities utilities.df.norm, and we want those row names to be row names of utilities.df. Okay, I'll run that, and now you see the company names are now attached as row names. Okay, now let's find the distance using the normalized values. Okay, so let's call this d dot norm, and the same function dist. Now we use the normalized values, and then we specify method equal to Euclidean. Okay, and then let's look at the data. Okay, so now we have the new distances. So once we have the new distances, then we can apply the clustering methodology.